People have trouble with hypothesis testing. Not because hypothesis testing doesn't do what it's supposed to do, but because it doesn't do what people want it to do. I mean, people want it to do more than it's designed to do. What it's designed to do, it does well. So let's find out what hypothesis testing does do and what hypothesis testing doesn't do. Okay? We start off with what's called a null hypothesis. That's the hypothesis that's being tested. And the null hypothesis is invariably a default hypothesis. That's the one people believe is true unless you can get sufficient evidence to say it's not true. It's the assumed true thing. So when someone sets up a null hypothesis, they had better set up the one which is the default, the one assumed true. We're going to make an analogy in hypothesis testing to courtroom. In a courtroom, a man is innocent until proven guilty. That means he is innocent. That's the null hypothesis. Null hypothesis is that he didn't do it. Now, you want to say he did it, you better have sufficient evidence to convince this jury beyond a reasonable doubt. If there's really any doubt in the jury's mind of his guilt, this guy's going to go scot-free. So you're going to have to really come and prove he's guilty. The null hypothesis is that he's innocent. Now, that's the way the judicial system is set up. It would be horrible if a system were set up so that a man pulled in by the police would be guilty unless he could prove himself innocent. That would be pretty bad. So you can't choose which you want to be the null hypothesis. The null hypothesis has to be the default, the one that's true if nothing is done. Otherwise, the whole system is a mess. And unfortunately, you will see lots of people who make a mess out of the system. The system is often misused and abused, and the key to making sure that when you first start, that you're not misusing it or abusing it, or others aren't, is that the null hypothesis, the thing being tested, is the default, the one that's going to be assumed true if they don't do anything whatsoever. Okay? Now let's see. What can a statistical test of hypothesis do? What can it do to this null hypothesis? There's really only two things it can do, one of which is significant, and that is it can reject the null hypothesis. That means there's sufficient evidence to convince a jury that it's wrong. The null hypothesis is that he's innocent. If you can convince a jury that he is not innocent, beyond a reasonable doubt, then they will say he's guilty. Guilty means reject the null hypothesis. Reject the null hypothesis. Say the null hypothesis is not true. It is not true. I am convinced it is not true. Absolutely convinced it is not true, beyond a reasonable doubt. Okay, that's one thing it can do. The other thing it can do is it can fail to reject the null hypothesis. There's just not enough evidence. The evidence is insufficient to convince the jury. Oh, you've done a fair job of convincing me, but it's not beyond a reasonable doubt. It's possible. I'm not really, I think he probably did it, but I'm not that. It's possible he couldn't do it. So we'll just have to let him go. You have to convince me beyond a reasonable doubt, and I'm convinced, but there is some doubt. All right? So you can either convict them and say, I reject your innocence. There's sufficient evidence here. They've piled it up against you. There's no way. You got to be guilty. Or, well, I don't think, you could say, I don't think you're guilty, but really it means is there wasn't enough evidence. I mean, the evidence was not convincing, not that convincing. It's possible that he didn't do it. There's only two ways. Now, this possible is not, doesn't mean he's innocent. We'll get to that again. A guy can be really guilty, but they did a lousy job in proving it. And we'll have to let him go because there's a reasonable doubt. And what I want you to note, and if you can remember this, you will be doing something pretty good. Note, a statistical test of hypothesis cannot be used to prove a null hypothesis. We cannot prove the innocence of a person. We don't have to prove the innocence of a person. Someone has to disprove it. The null hypothesis does not have to be proved because it's the one we will believe if we do nothing. So why does anyone have to prove it? Just do nothing. Do nothing and the null hypothesis is believed. So why prove it? You don't have to prove it. It's already established. And that's one of the problems in the understanding of hypothesis testing. Hypothesis testing does not prove anything. You cannot prove a null hypothesis by doing a test of hypothesis on it. So when you see these statements in the television that someone has proved something, statistically, you know this is shaky, very shaky, because statistics cannot prove a null hypothesis. There must be some other mechanism at work, not simple hypothesis testing. Okay, the big sham. The big sham. Now, I'm sort of overstepping things here by being really, really mean about this to statisticians. Normally, let me go back for a moment. I've been telling you how people who abuse statistics, who use statistics but don't really know what they're doing, have just used the words wrong. But, gee, us statisticians, we're saintly. We never use the wrong words. We always do it right. Well, no, we make mistakes sometimes, but we'll admit, oh, gee, I should have said sample standard deviation when I said standard. That's fine. I'm not talking about that. I'm talking now about a word that's accepted by the statisticians. It is a poorly chosen word because it has a meaning in everyday language, and when a statistician uses it, it confuses people who think they mean something else. And the word is the word accept. The word accept in statistics means fail to reject. In statistics, when someone is doing hypothesis and they use the word accept, it is a jargon word. It is not a word, it is not the English word accept, spelt the same way. It is totally different. It does not mean accept, it means fail to reject. One never accepts the null hypothesis. However, one might accept the null hypothesis. Now, what do I mean by that? Is play on words? Well, yes and no. What I mean by that is you can't prove the null hypothesis. So the fact that you haven't disproved it doesn't mean it's true. Man, you go into court, you're in a jury, and this fellow was accused of killing 3 people, and someone saw him do it. 2 people saw him do it, and he was there. He hated the people. He had the gun had his fingerprints on. They found it smoking in his hand. But the defense attorney is really good, and he shows that the guy who saw him do it has astigmatism, and the other one had a bad contact lens, and that his fingerprints was slightly smudged on the gun, and things like that. And you say to yourself, well, you know, he's casting some doubt on the situation. So since there's some doubt there, and the judge said I have to do this beyond doubt, well, all right, not guilty. They just didn't prove it. They just didn't prove the case, so not guilty. You're not going to invite this fellow home, meet your family, and have dinner with you. You kind of feel he probably did it. Yeah, he probably did it, but I just couldn't convict him. You're not accepting his innocence. You're letting him go. You're failing to reject his guilt. You're failing to reject his innocence. You're not accepting his innocence. Failing to reject is not the same as accepting in the English language. There's a wide difference between accepting and failing to reject. However, in statistics, accept means fail to reject. Okay? So you can accept the null hypothesis, but there's no statistical procedure which will allow you to accept, that is, to prove the null hypothesis. All right? If we got that, we're doing great. If you got that, you're home free. Next is just some nomenclature and some how to do it, but the concept is that. You've got the concept if you understand that. If not, sort of go back and see it again. Let's talk about some errors. Type 1 error, also called the error of the first kind, is when one rejects the null hypothesis when it's correct. If you take a true null hypothesis, if you convict an innocent person, you are committing an error of the first kind. And statistics considers this a very serious error. A very serious error. Convicting an innocent person is something we should try to avoid at all costs. We want to avoid it. Okay, let's define the size or level of the test. It's associated with a type 1 error. Actually, the size or level of the test is the probability of committing a type 1 error. I always say size or level of test is the type 1 error, but people always catch me and say, oh, that's not exactly correct. The size or level of the test is the probability of doing this, of making this error. It's not the error itself, it's the probability of the error, the chances of making that error. When the judge says beyond a reasonable doubt, he means make sure there's a very small chance of your making a type 1 error, of your convicting an innocent person. And in statistics, we like to use specific probabilities. We're going to use like 10% or 5% or 1% as our errors, or often called a 0.1 error or size or level, or a 0.05 level, or a 0.01 level. Those are the levels of the tests we're going to be working with in statistics. So type 1 error is convicting an innocent person, that is rejecting a null hypothesis when it is indeed true. There's another kind of error, and that is a type 2 error. That is when we accept or fail to reject the null hypothesis when it's wrong. That is, let a guilty person go free. Now, the courts and statistics do not consider that anywhere near as important or critical as the type 1 error. Okay? So what we do in statistics is we fix the size or level of the test. That is, we say, listen, jury, I don't want you to be wrong more than I don't want there to be more than a 5% chance of your convicting an innocent person. Well, do the best you can now. If he's guilty, I very much like you to say he's guilty. But do not send him away if there's a chance he's innocent. Okay? So what we do is we fix the size or level of the test, and we hope we don't have too much of a type 2 error. We do the best we can with type 2 error. That's not too hard. We make sure that we are reasonably confident. 5% chance, maybe a 1% chance, depending on how reasonable a judge wants us to be. And we do the best we can with that restriction. With that restriction, we want to catch as many guilty people as possible. But we want to make sure we're not so hard-nosed that we convict very many innocent people. So with the restriction that, hey, we can't convict very many innocent people, we do the best we can in figuring out whether he's guilty. After all, we could always just flip a coin and not convict very many innocent people. But we want to, with the restriction of no more than 5% or 1%, whatever, of the innocent people, we want to catch as many guilty people as possible. And the statistical procedures that we're going to come up with do that. They fix the size, and they do the best they can with respect to the type 2 error. We may never know what the type 2 error is, but we know we're doing the best we can with respect to it. Now, how do we do this? We're now going to do this thing. Statistical tests can be done using confidence intervals. So right now we're actually going to do statistical tests. Example, how to use statistical tests, how to use confidence intervals in doing statistical tests. Let's say we're asked to make a 5% level test. That means we can't be wrong more than 5% of the time. That means we got to be right 95% of the time. That means we must be 95% sure that the null hypothesis is wrong before we reject it. In order to reject the null hypothesis, we have to be 95% sure that it's wrong. If we're, let's say, must be at least. Of course, it's okay to be more, right? We must be at least 95% sure that it's wrong. If we're at least 95% sure that it's wrong, then we won't be making more than a 5% error. The error will be less than 5%, and that's what the judge said. He said, well, no more than 5% chance of making a mistake. Okay, that means I must be 95 or more % sure that the null hypothesis is wrong, that he's not innocent before I convict him. Well, how can I do that? Easy. By the way, if I want to be 1% sure, a 1% level test, then I must be at least 99% sure that it's wrong. And I want to point out the ridiculous meaning of the word accept, and that it's not really the English word accept. If the judge says you got to be 99, you make a 1% level test. That means you got to be at least 99% sure. Well, what if the data comes in and people point at him, yeah, he looks guilty, and you're 98% sure that the guy is guilty. 98% sure. Certainly you don't think he's innocent if you're 98% sure he's guilty. Clearly, he's not innocent. You won't accept his innocence when you're 98% sure he's guilty. However, you must fail to reject. You can only reject if you're 99% sure or more. Well, you're not 99% sure. You're only 98% sure. You're not sure enough to reject the null hypothesis at the 1% level. You must fail to reject. You must accept his innocence. You accept someone's innocence when you're 98% sure they're guilty. You accept the innocence when you're 98% sure he's guilty. That's the ridiculous meaning of the word accept. It is not the English word accept. You would never accept someone's innocence when you're 98% sure they're guilty. But in statistics, we accept their innocence because we're only 98% sure. Okay? Let's see how we do this numerically. The mean height, null hypothesis. H0 means the null hypothesis. Okay? The null hypothesis, the mean height is 72. Or, make it simple. Joe, my friend's a basketball player, and I think his height is 72 inches. He's 6 foot tall. Well, not much of a basketball player. He's 6 foot tall. That's what I'm saying. Let us say that we took a sample. We measured him a few times, and we made a confidence interval. We know how to do that. Let's make a 95% confidence interval. Let's say I want to make a 5% level test. I want to test this hypothesis at the 5% level. So I will reject it if I'm really convinced it's not true, and I will fail to reject it if I'm not really convinced that it's not true. Okay? So I get some data, and I make a 95% confidence interval. And let's say the 95% confidence interval comes out to be 65 plus or minus 6. 65 plus or minus 6 is 59 to 71. So what I'm saying is that I'm 95% sure that the true height, that his true height, is in the interval 59 to 71. I'm 95% sure it's 59 to 71. The null hypothesis is 72. I am 95% sure the null hypothesis is wrong. I'm more than 95% sure that the null hypothesis is wrong. I'm at least 95% sure it's wrong because I'm convinced it's between 59 and 71. 59 and 71 does not contain 72. It's outside. I'm sure it's wrong. 95% sure. I can then say, see, I'm 95% sure the null hypothesis is wrong. I can reject the null hypothesis at the 5% level. 0.05 and 5% are the same. I want to point that out. Sometimes we say at the 0.5 level, 5% level, the 0.5 level. Okay? So we've rejected this hypothesis from data which gave us this kind of confidence interval. Let's take another example. Same example, so to speak. The mean height, 72. All right? Joe's height, Joe's 6 feet tall. Let's take a sample and obtain a 95% confidence interval of the form 65 plus or minus 7. Right? It's just some different data. We got 65 plus or minus 7. We can say we're 95% sure that the true height is in the interval 58 to 72. 58 to 72. Note, 72 is in this interval. It's in this interval. I am not 95% sure it's wrong. Of course, I'm not 95% sure it's right. It's right on the edge. I sort of think, hey, gee, it just barely made it by the skin of its teeth. I don't really think 62 is right. He's probably a lot shorter than that. But it made it. It made it into my interval. I cannot say that I'm 95% sure that it's wrong. So we are not 95% sure. We're a little less, maybe 94% sure, but not quite 95% sure. We're not quite 95% sure. If we're not 95% sure, we must fail to reject at the 5% level. Because in order to reject at the 5% level, we must be 95%, at least 95% sure that it's wrong. We are not 95% sure, therefore we must fail to reject. And when we fail to reject, the statistics will tell us, the books will tell us, accept H naught at the 5% level. Accept H naught. But remember, this accept is really the jargon word accept. It is not the English word accept. We fail to reject. That's all we are doing. Fail to reject. We use the word accept. Why am I upset about that? Well, I get the feeling that the reason it's done is because statisticians, if someone wants you to prove something, Crest is the best toothpaste, all right? That's my null hypothesis. I failed to disprove it. Not enough evidence to disprove it. Well, they didn't really want me to disprove it. They wanted me to prove it. I can't prove a null hypothesis, so I failed to disprove it. It could be the best toothpaste, but so could any of the other toothpaste be the best toothpaste. So I go to them and I say, well, I have failed to reject your hypothesis. And they say, well, I failed to pay you then because you haven't done anything. So I say, oh, no, I'm sorry. I mean, I accept your hypothesis. Oh, great. Here's your money. They pay the statistician his money and they go and broadcast, Crest toothpaste has been accepted by the American Dental Association to be the best toothpaste. All it means is it hasn't been rejected. And they can say it on the airways because it's a legal word. It's just not the word we think it is. And I'm very unhappy about the use of that word. I think it's a sellout, personally. And I would be happy if you don't use it. Don't use the statistical word accept. All I want you to do is know that others may be using it, and so that you can understand that what they're doing is deceptive. It's really, really deceptive. And look through it and say, hey, they said accept. That means they mean failed to reject. That means really they didn't do anything. Let's summarize the steps needed for testing a hypothesis. You set up your H naught. You set it up, that's the default. Remember, the default. Not one you're trying to prove. In the Crest toothpaste example, they were trying to prove something which was not accepted already. If it was accepted already, they could simply go on the air and broadcast, the American Dental Association accepts Crest as the best toothpaste, and not have done any experiment whatsoever. But it wasn't, so they did an experiment and trying to prove that it was accepted. Can't do that. You can only set up the one which is the default, already accepted. That way, if someone uses the word accept, it won't be so bad. Decide on the size. You want a 10% level, a 5% level, a 1% level. Actually, using confidence intervals, all we can do at this point in time is a 5% and a 1%. Those are the only ones we know how to make intervals for at the moment. Then we make the confidence interval. That is, make the corresponding confidence interval, which is the 95% interval, and the 99% interval. So if you want 5%, use 95% interval. If you want 1%, use 99%. Then you see if H naught is in the interval. That is, there's a number that's in H naught, inside the interval or not. If it's in the interval, you must fail to reject. If it's outside the interval, you can reject. So you reject or fail to reject H naught, depending on whether the null hypothesis is in the interval or not. In the interval, fail. Outside the interval, reject. Okay? That's how to do hypothesis testing. And next time we're going to expand on hypothesis testing and expand it in several directions and make things more realistic. Okay? Have a good one.